Hello, this is John Malmesbury with Edis Research, and I'm putting this video together to give a basic overview of one of the examples provided with Precog. So to get this started, go to your Precog source folder, examples, and we're going to open Radio Higher and Simple TRX. Okay, so what's going on here is we have a layered approach to implementing a simple radio, and the radio top lock is, as you may have guessed, kind of the phi and lower MAC layer. So this provides modulation, demodulation, access to the USRP, and then some high-level framing and deframing with CRC and things like that. The layer above that is implemented with this simple MAC block, and this provides some additional framing functionality with radio addressing, and it also provides ARQ functionality, relatively simple implementation of stop and wait that we may enhance later, but it was just an interesting way to show how to implement things in Python with GR extras. So what you see here is that there are simple interfaces between the radio and the upper layers. Basically what you have going back and forth between them is raw data, which in this case is some frames to and from the simple MAC block. But they could be other things. You don't necessarily need to use this block. And then the simple MAC block also provides an application interface which could go to one or more endpoints. In this case, we just have it going to a simple socket message block from GR extras. This provides basically a TCP/IP interface, so you could connect with a socket and just exchange data with the flow graph through that socket. This block here, when you have more than one radio operating, this block takes the stream coming from socket message and encodes the key of that message so Simple Mac knows how to manipulate it correctly. In this case, it shows that it's going to be sending the messages from this block to a radio with the address of 86 and with ARQ, and you notice you can turn ARQ on and off depending on the type of data that you're sending, the throughput, and whether or not you need guaranteed delivery. Now you see some addresses here. This is the address of the radio itself, and this is the address of the destination, the radio we're trying to send messages to. And as you can see, those are both parameters which can be accessed in the command line. So this block is implemented with Python, and that's simplemac.py. But let's take a closer look at radio top lock and see what's inside that. As you can see, it's a relatively simple flow graph. There's not really any MAC functionality at this layer in this particular block, but we do also have TDMA and frequency hopping blocks that are a little bit more involved from the MAC aspect. Here you have a USRP source, it's complex samples, GMSK demod, and then a deframer which has a correlator and some packet utilities inside of it to deframe things and check the CRC, etc. And then the resulting blob that's created from that is sent out through this port called message out, and as you can see, that message out is goes to the input of the simple MAC block. And here it's kind of the opposite. You have messages coming in from the MAC block. It gets framed, modulated. We do multiply constant to avoid saturation of the mixer. We have this burst gate, which is kind of a band-aid for tag placement through an interpolating chain. Basically what this does is it moves the end of burst to the absolute last sample of a particular frame, so that the whole frame gets through the transmission path of the USRP, which of course is the sink for this chain. We're not using it in this example, but there is also some control plane functionality provided by the PMT RPC block and the control in, control out ports. So now we're going to do some work just to operate these two radios. So what you don't see is that I have two USRP N210s on my desk through 1 gigabit Ethernet interface. Each of those has a WBX and an antenna on the TX-RX ports. So this is a half duplex operation, which is enabled with the burst tagging features of the USRP. So I've already kind of got this ready to go, just so it's not so long to type it out. But so essentially, this says that TCP/IP socket is going to be open on 12345. The address of this first radio is 85, and it's going to be sending messages to 86. And this is the USRP we're accessing. So we'll start him up. On this guy, we'll kind of do the opposite. We'll give him his own point, or own port, 12346, and the addresses on this one will be swapped. So this is 86, and he's sending messages to 85, or this radio here. And we can start him up. Next, we're going to do netcat and connect to each of these flow graphs through that socket message block. And we're just going to send some simple messages back and forth. So you can see here I type in this message that's sent to the socket on the local host 12345. That's turned into a blob on the flow graph, is sent through SimpleMac through the radio over the air, and it gets demodulated by the opposite radio, which is here on the right. And I can try going the other direction. So what you can't see here is behind the scenes, SimpleMac is running ARQ, and the simplest way I have to demonstrate that is to pull off the antennas of the radios, which I'm doing here. And if I try to transmit again, antennas are off, you see that the message does not go through, and the radio retries the sending of that message, but after you get to a certain point, we do set a threshold on the ARQ where after so many attempts it kind of gives up and would echo that failure to the application layer, so that a single message isn't kind of clogging the chains. And of course we can make it fail going in the other direction as well. So I'm going to put the antennas back on, and in this process I've discovered a small bug. So the first message I send will not appear on the opposite radio. I'll fix that before I post, but you can see I put the antennas on, and the messages are making it over the air again to the opposite radio. So that's a pretty basic example. We'll post more complicated ones that show TDMA or multiple endpoints and muxing. But that gives you a rough idea of what you may be able to do with Precog right in GRC. So with that, I'll conclude this video, and more details will be forthcoming.